Hello and welcome to yet another video of Cornerstones of Math. In this video, I will discuss about angle bisector. For example, these two red lines shown in the figure, 4x minus 3y minus 11 equals 0 and 5x minus 12y plus 11 equals 0, meet at the point 5, 3. Then, can you find the equations of the angle bisectors between these two red lines? There are two angle bisectors, by the way, the one that bisects the smaller angle between two lines and the one that bisects the larger angle between two lines. I will present you two methods. The first method is what I call distance method, and the second method is what I call vector method. And as indicated by their names, the second method involves vectors, while the first method does not. And here's another important thing. In my opinion, for this problem right here, the first method is the simplest method. And since it does not involve vectors, this is the method that can be used by students who do not have any knowledge on vectors. Then why do we ever care about this second method? Well, this problem can be solved by two methods, but only because it is a two-dimensional problem. And when it comes to 3D geometry, you absolutely need vectors to express directions and lines. So when you think of 2D and 3D together, this vector method actually becomes the more general method and thereby the overpowered method. But for now, let us take a look at the method that's powerful at least in 2D. The distance method. Here's how it works. Consider an arbitrary point P on the angle bisector. Let us express its coordinates as capital X, capital Y in order to distinguish them from small x and small y, which are used in more general sense. Again, this P is an arbitrary point, so it basically represents any points on the angle bisector. But regardless of the position of P, we can say the following. Let us draw a fit of perpendicular from point P to two given lines and call them points Q and R. Also, we have this intersection point, and let's call them point S, which in this case is 5, 3. Then, from triangles PQS and PRS, first we have angle PQS equals angle PRS, but they are not just equal, they are also right angle. Next, side PS, which is hypotenuse, is common. Next, angle PSQ equals angle PSR due to the angle bisector condition. Therefore, triangles PQS and PRS are congruent by the condition of RHA congruence, defined by having equal right angles, hypotenuses, and another corresponding angles. Due to this congruence, we have length PQ equals length PR. That is, point P, an arbitrary point on an angle bisector, is equidistant from two lines. Therefore, the problem of finding the equation for the angle bisector can be rephrased like this. What is the locus of the point P that is equidistant from two lines? And I've said this many times in my locus videos, that finding the locus of the point x, y means finding the relation between these two variables x and y. And we can find that relation using the equidistant condition we have just verified. Using the formula for the distance between a point and a line, the distance from point P to this line is absolute value of 4 capital X minus 3 capital Y minus 11 divided by square root of 4 squared plus minus 3 squared, and the distance from point P to this line is absolute value of 5 capital X minus 12 capital Y plus 11 divided by square root of 5 squared plus minus 12 squared. And these two distances are equal. Here, this denominator is 5 and this denominator is 13. So we have 13 absolute value of 4x minus 3y minus 11 equals 5 absolute value of 5x minus 12y plus 11. Here we have absolute value signs on both sides, and the simplest way to remove the absolute value signs in this case is by writing 13 times 4x minus 3y minus 11 equals plus minus 5 times 5x minus 12y plus 11. So we have this, which means that we have to divide into two cases, one with plus sign and the other with minus sign. For the first case, we have 52x minus 39y minus 143 equals 25x minus 60y plus 55. So by moving everything to the left-hand side, we have 27x plus 21y minus 198 equals 0. Here we can divide both sides with 3 and obtain 9x plus 7y minus 66 equals 0. This is the relation between capital X and capital Y, the locus of point P. This means that point P, which is equidistant to two given lines, consists of the line 9x plus 7y minus 66 equals 0 on the xy plane. And you can easily notice that this is the line that bisects the larger angle between two lines. For the second case, we have 52x minus 39y minus 143 now equals minus 25x plus 60y minus 55. So now we have 77x minus 99y minus 88 equals 0. So we can divide both sides with 11, which gives 7x minus 9y minus 8 equals 0, which means that we have obtained the line 7x minus 9y minus 8 equals 0. This is the bisector of the smaller angle between two lines. So we have obtained two angle bisectors. And from the equations, we know that these two angle bisectors are perpendicular, which is consistent with basic geometry.